Hello everyone. Today I want to illustrate my project that I'll be working on, and the is going to be to drop a bar of soap into my hand. So I figured that I'll be using this string, and what I will be doing is I will be attaching the string to there's gonna be like a platform, so to speak. It's gonna be something flat, and my idea is gonna be that the soap is gonna be on top of this platform, and this is gonna be taped through the back against the wall, and so this string will be connected to the other end, and it's gonna make it stay horizontally at 0 degrees. So the string will be like this, and if there was no tension on the string, and if the string was loose, this would just come down like this with an angle, and the soap would drop. So by default, it's gonna be flat, and then the string is gonna be on a sort of a pulley, you can say. It's gonna be attached to a pole, which is gonna be um, the the pole is gonna be the top of the shower curtain, and the bar of soap is gonna be sitting on a platform connected to the wall by the shower. So then the string is gonna go over like this, and it's gonna go over the shower. And then there's gonna be a pole that's gonna go right over it. And before we get to that, before the string goes into the over the shower, so the string, again, we have a platform, it's attached, and right after the attachment, I'm going to be tying it to something like this, and it's going to be just hanging in the air. This will create weight, and when the string is loosened, the weight will just go down, causing this string connected to the platform for its angle to drop below the horizontal, the x-axis. And there's going to be a critical, I should say, a critical angle where the soap will just stay there as the incline increases like this. And there's going to be a point where when this incline exceeds the critical angle, the soap will have enough, the friction force that's holding the soap together will be offset by this increase in angle, as well as the weight of the soap. So, as we know, the normal force would just be pointing like this, and then the weight would just be pointing straight down. So the soap will begin to slide down, okay, and it will slide off the platform. But I'll get into that in a second. So back to this. We have the string that's going to be attached to this. And on the other side, I will have another piece of string. And hold on, let's just. So we will have another piece of string connected over the shower curtain. Again, it's going to be a shower curtain. And, well, on this side of the string, what we're going to have on this side is going to be basically this chair where I'm sitting at. So I can possibly attach this to the chair, and then my idea is going to be that the chair is going to be right against the door of the bathroom, and then when, say, I walk into the bathroom, come in through that side, I open the door, and the door will cause the chair to push forward. So what will happen is the chair will begin to roll forward. The wheels on the bottom of the chair will have a friction force. The floor will, and the wheels, there will be a friction force that will cause the chair to slow down, and a push force. So the push force is going to go into the bathroom, and then the friction force is going to go in the opposite direction. So the chair will begin to move forward, and the string attached to the chair, before I open the door, the string is going to be like this. It's going to be straight. But when I open the door, the chair will push the string, and this will cause the weight over here. It will basically, the way it will happen is that the tension force on the string, on, say this is the curtain, the side into the bathroom with respect to the side into the shower, where this side, since the chair is already on the ground, the chair, when I open the door, the tension on the string will be basically zero. Before I open the door, there's tension on the string that overcomes the tension force that's on this side that is caused by this weight. So this weight that's on this side has a smaller tension force, and the tension force on this side caused by the chair, because the string is firm. So when I push the chair forward, that tension force goes to zero. So you have a zero tension force over here, and then a positive non-zero tension force over here. This means the string will, since there's more force on this side, the string will do this. Now, when that happens, this thing will go down. It will be displaced in the negative vertical direction. It will go down and slide down a little bit. When that happens, the angle that the string is attached to the platform of the soap will begin to, this angle will begin to increase in the negative direction with respect to the x-axis. Or you can look at it like this. This is the horizontal, and this is the platform where the soap holds. So there's going to be an angle right here, which is below the x-axis. Eventually, this angle will cross a critical angle. We could look at it the other way over here on the other side and measure this angle. When this angle goes above a certain critical value, the weight of the soap and the friction coefficient of the platform, this is what holds the soap there. The greater this coefficient, the greater the angle. So what happens is that this angle, as this is leveled down, this angle will increase until the soap will slide. It will slide off the platform. And when it does, it's going to land on a slide that's going to be attached to the wall, like this, at the bottom, just underneath the platform. There's going to be a slide. The soap will land on it, and it's going to be a slippery slide, which means that the friction of this surface is going to be a lot smaller. It's going to be very slippery. So the incline, the plane doesn't need to have that of a great angle for the soap to slide down, since the surface will be very slippery. So the soap will travel through this platform, and it will come around. And as I walk into the door, so I'll illustrate. So like, say I'm right here, and I open the door. So here's the door. There's a chair. There's the wheels on the chair. And right here you have the floor. This chair will have a forward push force. So we have push force. And this force caused by the door opening will, obviously, we have a friction force in the opposite direction. And we have the weight force, which at this point are not that important in this case. And we have the normal force. So then the string that's connected to the chair, so the string connected, the string is going to be connected to the top of the curtain pole. And it's going to be like this. It's going to go right over it. It's going to go right over it. And the tension force, you can say TF, or tension force, or T1 or T2. The tension force here will be a great value as long as the chair is against the door. Once the chair moves, this tension will go to 0. And over here, we have this ring device that's attached to it, which has a weight equal to X amount of newtons. So this, okay, so the string goes over the pole, the curtain, and this ring with an X amount of newtons with will cause a tension force that's non-zero, a non-zero tension force over here. So there's going to be force, tension force. And when the tension force on this side is 0 and the tension force on this side is some positive value, the string will begin to move in this direction. And then the ring will drop. Okay, so the string that's connected to the ring will just, let me erase this real quick. So connected to that ring, okay. So the ring is going down as when I open the door. And this ring that's going down is being displaced vertically. It's connected the string to another string that attaches to the platform where the soap is. And we have soap right here. So this means that as this goes down, there's going to be, this thing is going to do this. Here's the wall, and it's going to go like this, and it's going to have an angle of theta. And this angle will continue to widen with respect to the x-axis. Okay. The friction of the platform with respect to the soap and the weight of the soap will determine how big this angle needs to be for the soap to start sliding down. When that happens, there's going to be a slide, which is going to be connected over here. Slide. And slippery. It's going to be of a slippery type of material. And as I go inside the bathroom, I'm going to walk into over here, and my goal is for the soap to land in my hand. So the soap will go traveling like this direction, and it will drop into my hand. So that is basically um, my project of having a soap drop in my hand. This is something that I'll be working on and, getting it better. I hope you all enjoyed it. Thank you very much.